A particle moves in a horizontal line. Its displacement x meters from the origin at time t seconds is given by x is negative t cubed plus 21t squared. Take away 135t plus 230. This is not an easy function to deal with, and a lot of this question is going to be calculator work. Sketch the displacement function of this particle for the first 11 seconds on the axes below, marking all important points. So I've plotted the graph here using the same sort of scales that I've got here. And what I want to do is get the key features. Now the first one would be this y-intercept, but that's easy to find without the calculator. It's just going to be at 230. So that's just going to be here. The next thing is probably this x-intercept. So analysis gsolve, and of course those are called roots. And that's at about 2.68. So let's just mark that here. And so that's at 2.68, 0. Then we've got a minimum point just here. So this is gsolve. Let's find minimum. And here it is. It's at 5, negative 45. So 5, negative 50 is this line. So it's just a bit above there. Then there's a maximum. And it's found that. That's at 9, negative 13. Which is about here. So 9, negative 13. Finally, since I'm plotting in a range, I'd get the end point. So go back to gsolve, and I want a y-calc when x is 11. And that gives me 11, negative 45. So pop that on there. And then we want to try and get a sketch of the function. I've produced a rough sketch of the curve now. Find when the particle is at the origin O. Well, we know that this is displacement and time, so it's when the displacement is 0, so it's this intercept here. And it says when, so we want the time, so that's approximately 2.68 seconds. When did the particle turn around and travel towards the origin? Well, this is a turning point. It was travelling away, and then at the turning point it started to travel back towards the origin. We can see that because it's travelling towards the t-axis here. So that's when t equals 5. It does say when, so we want time. We want to find the total distance travelled in the first 8 seconds. Well, in these first 5 seconds, we put the origin here. It starts at 230 this side and comes down to negative 45 this side. So that's 275 meters. But then it's travelling back towards the origin. We need to know how far it's travelled when we get to t equals 8. So get the calculator out. And we're doing a y-cal again. When x is 8. And that gives us negative 18. So what we need is 45 take away 18. It's 27. So this is 27. So it's travelled back here and then forward a bit. So that's 275 add 27, which is 302 meters. Is the particle increasing or decreasing speed at t equals 4 seconds? Show calculations to justify your answer. Note we're talking about speed, not velocity. So, v, we know, is the differential of this, so that's minus 3t squared plus 42t, take away 135. And we want v of 4, which is negative 3 times 4 squared plus 42 times 4, take away 135. Let's just grab the calculator for that. So we've got negative 3 times 16, add 42 times 4, take away 135, so that's negative 15 meters per second. And all that means is it's going 15 meters per second to the left. To get acceleration, we'll differentiate this. So that's going to be negative 6t plus 42. So a of 4 is going to be negative 6 times 4, add 42. So that's going to be 42, take away 24, which is 18 meters per second squared. Now that means the acceleration is to the right. So if we look at this particle, its velocity is this way, but the acceleration is in the opposite direction. So it must be slowing down. At what time between 5 and 9 seconds was the particle travelling the fastest? Justify your answer using calculus methods. So here's 5 and here's 9. So we're talking about along this section. The steepest section along here would be at the point of inflection. So we want to find the point of inflection. Well, we already had the second derivative. We could find it from the graph, but it does say use calculus method, so we should show some sort of calculation. We had that the acceleration, which was the second derivative, was negative 6t add 42. So a would be equal to 0. The second derivative is 0, giving us 6t equals 42. So t is 7 seconds. And of course we could find that from the calculator. So if we go back to the graph and table. So we need to plot the graph again. And then analysis, G-solve. And it wants an inflection point, which we find is at 7